All right, it is now starting. We got section 10.6. The last surface area and volume is for pyramids and cones. So let's label a few of our pictures here. This is our pyramid, and we've got a height. Now, if you notice, the height is a dotted line that you would not be able to see that would be inside the pyramid from the top of the pyramid straight down to the bottom. The height, the H height, is always at a 90-degree angle. You can see right here, 90 degrees. Now, the L stands for what height? Slant height. So that's our slant height. We call that letter L. And that's at a 90-degree angle, but it's on the sides, and it's on a diagonal to the pyramid. And then this triangle right here has a name. All the triangles actually have names. What do we call the triangles in that pyramid? Okay, what kind of faces? Lateral faces. They're the faces that are around the outside. So that's our lateral face. Now for a cone, we've got some of the same type of things. So we've got our H, again, that's going to be our height. That's inside the cone that you cannot see, so that's why they make it a dotted line right here. The L is a solid line that you would see going up the side of the cone, and that's your slant height. A slant. And then just the around the outside, we would call the lateral surface. Now it's not a lateral face. Faces have to be polygons, like triangles or rectangles or squares. But lateral surface would be where there's a curve. And then this bottom part right here is our radius. R is our radius. To find, we're going to talk about volume of both of these. So how does the volume of a cone compare to that of a cylinder with the same base radius and the same height? You want to write that down because we're going to take a look at that in a second. We're going to see what would happen if we had a cylinder that had the same circle base on the top and bottom and had the exact same H. And same thing for a pyramid. What if a pyramid had a prism that went straight up around it and had the same base on top and bottom? So we're going to see kind of what would happen. And I got a couple little videos that I want you to see, and I'm hoping that they play. Okay, so here's the first one. So you might have noticed that the pyramid was perfectly fit inside that of that cube. So they took the yellow stuff out so you can see that they're clear. The pyramid has the exact same base as the cube. So they fill up one pyramid and dump it in. And they fill out an identical pyramid, same exact pyramid. They fill it up. Pour that one into the cube or the prism. Might not actually be a cube, it might be a little taller than it is wide. Two of them go in. And your third one goes in. So can you see how the volume of a pyramid would relate to the volume of the same size prism? How would that relate? How many of these fit into there, right? Three of them. So to get the volume of the pyramid, all we do is take the volume of the prism and do what to it? Divide it by 3. There's 1/3 of it. Okay, so that's for the pyramid. Let's take a look at the cone. Now this one's a little different, just a little cartoon one. So it's showing you that the cone would fit exactly inside of the cylinder. Showing you that you could fill up one cone, and it's the same as the principle for a pyramid. You got 2, and exactly 3 of them would fit. Same thing with a cone. Cones and cylinders are exactly the same. You could fit 3 of them into one. So let's take a look at some formulas then. Here's the formula for a pyramid The volume would be, we would call it 1/3 big B times H. Now, what does big B stand for again? What kind of base? What do we talk about the base? Area of the base. So big B is area of the base. Okay, we got that right there. Big B represents area of the base, not just base. Now, I could also rewrite this formula like this. I actually prefer it like that because I don't like really dealing with fractions that much. So I would multiply the area of the base and times it by the height, and then just divide the whole thing by 3. Because that's the same thing as multiplying by 1/3, is dividing it by 3. Now remember, the H stands for what? The height at a right angle, not the slant height, not going up the side, it's the height of the pyramid or cone itself. The cone, the formula would be this: 1/3 times capital B times H. Now capital B we could actually rewrite as pi r squared. So you could put 1/3 pi r squared H. Or you could switch that to the same thing, which would be capital B times H divided by 3. Or you could put pi r squared H over 3. So you could do it either way, you'd have your same formula for a cone. That's how you find volume in the cone. So example 1 here is to find the volume of this pyramid. It's got a square base, a 6 by 6 base, and it's got a height straight up of 10. So they want us to find the volume. So I'm going to rewrite the formula, big B times H. And then and divided by 3. Now, how would I find the area of the base of this pyramid? 6 times 6. It's a square pyramid. So 6 times 6 is my big B. My height of this pyramid, straight up, 10. And then divided by 3. So you've got 36 times 10 on top, which is 360. Divide that by 3. You get 120 units cubed, or cubic units. We're still talking about volume is always measured in little cubic units. How many little cubes would fit? Now, of course, with a pyramid, some of those little cubes would have to be cut into pieces to make fit into there nicely, but there would be 120 of those cubes that you could fit in there, in that pyramid. All right. Example 2, if the volume of a square pyramid is 3,700 cubic centimeters, and the height of the pyramid is 16 centimeters, what are the dimensions of the base? Okay, now remember, this says a square pyramid. So we know the base is a square. You're going to have x times x here, right? So what we want to do is rewrite our formula, base, area of the base times height divided by 3. So in my picture, what can I fill in? I can fill in height. Okay, so we can do that. What else could I fill in? What is it? What can I fill in? The volume. So I know that this whole thing is going to equal 3,700. And what about the area of the base, the big B? So I just put x? X squared. Good, because we know that to get the area of the base, I'd have to do x times x. So big B would be x squared. All right, what do I do first to solve that? Multiply times 3. Let's get rid of any decimals that or any fractions that we see. So you'd have 16x squared equals 3,700 times 3. All right, so we got 11,100. We divide by 16. Well, let's see what that is. Divide that by 16. Get 693.75. Then you're going to square root both sides. So 693.75, and we want the square root of that to be 26.3. So the pyramid would have a square base. They'd both be 26.3 on all four sides. Would be 26.3. So that is, those are pyramids. That would be finding a dimension. The other one was finding the volume. You use the same formula. If they give you volume, you can use the volume formula. Okay, moving to the cones. Okay, so X came out to be 26.3. Now we're moving on. Okay, find the volume of the cone in this first one over here. So let's rewrite the formula underneath. Volume equals big B times H, or pi r squared H, and divided by 3 on both of them for our volume. Since it's a cone, we have to divide by 3. So let's plug in what we know. This time we're trying to find volume, so we need to leave the V equals. Pi r squared would be pi times 6.3 squared. And then times the height, which is 10.6. And we're going to take that all and divide it by 3. Okay, so you get 1,321.7, and we're going to divide that by 3. So take that, divide it by 3, and you get 440.6 when you round it off. And that would be in cubic inches. Inches cubed. That'd be our volume. So just plugging in the formula. If you know the formula and you can find the pieces, you can solve it. An extra example here, a cone-shaped paper has a height of 5 inches. The cone must hold 50 cubic inches of water. You ever seen those little cone-ish water cups that you can pull out of the thing and you can drink it like a cone? So it needs to hold 50 cubic inches of water. What radius should you make the base of the cone? So it's got a height of 5. We don't know the R, and we do know that the volume has to equal 50. So if I put my formula, pi r squared, divide by 3 times h here, what would I plug in? I'd plug in the volume. Okay, so I plug in the volume, which would be 50. So 50 equals pi times r squared times what? 5, and then divide by 3. So we're going to try to solve for r there. So bring down, let's first multiply both sides by 3. We can do that first. We get 150 equals, the 3's will cancel out, and you get 5 pi r squared. What do we want to divide both sides by? By 5 pi. Get rid of the 5 and the pi. So take 150, divide it by 5 pi. Now that you may have to put in parentheses. If you're doing the whole thing in your calculator, you'll have to put the 5 pi in parentheses. You'll get 9.55 equals r squared. And then you'll need to square root both sides to get radius. So take the square root of 9.55, 3.1 when you round it off. So this radius right in here would be 3.1 inches. 3.1 inches. Okay, a little critical thinking. If you're given the radius, okay, look up in this first one, you're given the radius, 6.3, and you're given the slant height. So let's say they didn't give you this 10.6 here. Let's say the 10.6 was this line right here. What would you, or how would you find the volume then? If they gave you radius and slant height, would you still be able to find volume? Okay, so yeah, you would want to write down in here that you'd need to use the Pythagorean theorem to find the height. So Pythagorean theorem would give you the height. Then you could plug it into your volume formula and get your volume of the cone. So that's what you're going to write in the critical thinking. Find the Use the Pythagorean theorem to find the h. Then plug in your radius and your height into the formula and solve for volume.